We have another example on the board. Please notice that we have given Z total, we have given resistance, we have given also voltage across the inductor, and we have given inductance. So what we can do first? In order to find voltage across the capacitor, I'm supposed to find the capacitive reactance. In order to find the capacitive reactance, I'm supposed to find basically X of L first. So I'm supposed to write the formula X of L is equal J omega L. So I have J times omega. Omega is equal 3 times 10 to the 6 radians per second times 300 microhenries. Okay, so I have omega times my inductance. This is equal J 900 ohms, or we can say this is equal 900 ohms, an angle of 90 degrees. So this is the inductive reactance in my series circuit. Next, please notice that we have given Z total. We have given Z total and we have given resistance. Also, we have given information that X of L is greater than X of C. So we can find very easy the angle which I'm going to have next to Z total. I'm going to use the formula for power factor. Power factor is equal cosine of angle theta, and if we talk about the series circuit, this is also equal resistance over Z total. In order to find the angle, I'm supposed to solve this part of the formula for angle theta. So this is equal to angle theta inverse cosine, and I have resistance over Z total, which is equal inverse cosine resistance is equal 500 ohms over Z total, which is equal 800 ohms. Everything is equal 51.31 degrees. And it's going to be positive. Okay, it's going to be positive because we have X of L greater than X of C. In this circuit, X of L has to be greater than X of C. So anytime X of L is greater than X of C, the angle is going to be always positive. Next, I'm supposed to find X of C. So in order to find X of C, I'm going to use the formula which says that Z total is equal resistance plus X of L plus X of C. In order to find X of C, I'm supposed to solve this formula for X of C. So I have X of C equals Z total minus R and minus X of L. So this is equal Z total 800 ohms, and angle, we found the angle, is equal 51.31 degrees. You can use this formula because you have Z total with the angle. Minus R, which is equal 500 ohms, and minus X of L, which is equal 900 ohms, an angle of 90 degrees. Now I can write that X of C is equal 275.56 ohms, and angle of negative 90 degrees. So this is the capacitive reactance in my circuit. So if I have capacitive reactance in my circuit, I can simply say that I'm almost ready to find voltage across the capacitor. But please notice that we can use, in this case, voltage divider, or we can use Ohm's law. What I'm going to use? I'm going to use Ohm's law. In order to use Ohm's law, I have to find the current in this circuit. So I simply write that current, I total, is equal to current which goes through the resistor. This is also equal to the current which goes through the inductor, and this is also equal to the current which goes through the capacitor. Why? Because this is series circuit. In series circuit, current at every single point or at every single component is the same. So I can say that this is equal voltage across the inductor over the inductive reactance. So I have VL equals 24 volts over X of L is equal, which is equal 900 ohms. Right now I'm not going to add the angles because I make the assumption that my voltage source is supposed to have angle 0 degrees. I need to find just the magnitude. So I have current equals 26.67 milliamps. But keep in mind that we're supposed to also find the angle. In order to find the angle, you're supposed to write the formula which says I total is equal voltage source over Z total. We found that Z total has angle of 51.31 degrees. We assume that voltage source has angle of 0 degrees. We do this assumption in order to make the circuit analysis a little bit simpler. So I can write that this is going to be equal 26.67 milliamps, and anytime we divide the complex numbers expressed in polar forms, we're supposed to subtract the angle. So 0 minus 51.31 will give me negative 51.31 degrees. So this is my I total, which is also equal to IR, IL, and IC. That's why I can write the same angle which I wrote over here, also over here. So this is equal negative 51.31 degrees. Next, we're supposed to find the voltage across the capacitor. So I have X of C, I have current which goes through this capacitor. I can find VC. VC is equal IC times X of C, where IC is equal 26.67 milliamps and angle of negative 51.31 degrees times X of C, which is equal 275.56 ohms and angle of negative 90 degrees. This is equal 7.34 volts and angle of negative 141.31 degrees. Okay, so this is the voltage across the capacitor. If you are going to use voltage division law, you're supposed to get answer very close to this one. Next, we have to find the true power in the series circuit. So in order to do so, we're supposed to simply write that true power is equal 1/2 IR square times resistance. I'm using 1/2 because from the beginning I'm using peak voltage. Okay, peak voltage gave me also peak current, that's why I'm supposed to use 1/2 over here. So I have 1/2 times the current, 26.67 milliamps raised to the second power, times the resistance, 500 ohms. This is equal 177.82 milliwatts. Okay, so this is the true power in my series circuit. Now we are ready to find the power factor. The formula says power factor is equal cosine of angle theta. So I have cosine of angle 51.31 degrees is equal 0.625 lag. I have lag because my angle is positive, right? And because x of L is greater than x of C, and that's why total current is going to lag the voltage source by angle 51.31 degrees, and because it's lagging, I'm supposed to write word lag next to the value of power factor. Next, we have to find the current which goes through the resistor in the parallel equivalent circuit. So I'm going to have parallel equivalent circuit. We have voltage source, we have resistance, RP, and we have also inductor. Okay. Why inductor? Because x of L is greater than x of C. That's why there is no other option. We're supposed to get the inductor. So I have x of LP. Okay. So in order to find the current, I'm supposed to find first the total admittance. So Y total is equal 1 over Z total. So I have 1 over 800 ohms and angle of 51.31 degrees. Switch your calculators right now to the rectangular mode, and you're supposed to obtain the values of the admittance: 781.38 microsiemens minus J 975.67 microsiemens, where the real part of my answer is my conductance and the imaginary part is my inductive susceptance, BL. Now we are going to find the current which goes through the resistor in parallel circuit and current which goes through the inductor in parallel circuit. This time I'm going to use a little bit different way to do it. I mean, a little bit simpler but kind of longer, because I want to find first the resistance. RP is equal 1 over G. So I have 1 divided by 781.38 microsiemens. This is equal 1.28 kiloohms. Someone can ask why using this way. I would answer that I want you to practice different ways to solve this kind of problems. Next, I'm going to find x of L P, which is equal 1 over BL. So this is equal 1 divided by negative J 975.67 microsiemens. This is equal 1.02 kilo ohms and angle of 90 degrees. I express my answer in polar form because I prefer to work with angles. So in order to find the current, I'm supposed to also find the voltage. Voltage source is equal I total times Z total. But because I make the assumption that voltage source has angle 0 degrees, I'm going to use just magnitudes of total current and Z total to find voltage source. So I total we found is equal 26.67 milliamps times Z total 800 ohms. So voltage source is equal 21.33 volts. Okay, so this is the voltage source. So in order to find the current which goes through the resistor, Rp, I'm going to write I, Rp is equal voltage source over Rp, where voltage source is equal 21.33 volts over Rp 1.28 kilo ohms. This is equal 16.67 milliamps. Okay, so this is the current which goes through the resistor Rp. And if you want to find ILP, this is equal voltage source over XLP. Someone can ask why I don't use VR over RP or VL over RP. At this moment, you're supposed to understand that in parallel circuit, the voltage across each component is equal to the voltage source. So Vs is equal VRP, and this is also equal to VLP. So it doesn't matter if I'm going to use VLP, VRP, or Vs, the answer is going to be always the same. So I have 21.33 volts over XLP, which is equal 1.02 kilo ohms and angle of 90 degrees. This is equal 20.91 milliamps and angle of negative 90 degrees. So this is the current which goes through my inductor in the parallel equivalent circuit. Next, we can verify if our answers are correct. How I can do that? Simply add these two currents and you're supposed to obtain the value of I total. So let's check it. I total is equal IRP plus ILP. So I have I total equals IR, we found is equal 16.67 milliamps plus 20.91 milliamps an angle of negative 90 degrees. So I have I total equals 26.74 milliamps an angle of negative 51.43 degrees. Okay, so this is my I total. And we found before that the current was equal 26.67 milliamps and we had the angle negative 51.31. So even the answers look a little bit different, but the values are close, good enough to saying that up to this moment we are okay with our calculations. Now we are ready to find the true power in the parallel circuit. So I have true power in parallel circuit is equal 1/2, because I'm still dealing with the big values, and I have voltage across resistor in parallel equivalent circuit raised to the second power over Rp. This is equal 1/2 times, and we found the voltage equal 21.33 volts raised to the second power over Rp, and Rp we found is equal 1.28 kiloohms. This is equal 177.72 milliwatts. Okay, so this is the true power in the parallel equivalent circuit. Let's check what we got in the series circuit. In series circuit, we get true power equal 177.82 milliwatts. So we can say that these two values are very close to each other. That's why we say that the problem is solved correctly.